In this video, we're going to construct a histogram. Again, we're going to still use the same data that we've been using all along. So the first thing that we're going to do is find the mean and the standard deviation. We've already calculated those. The mean is the 68.8. The standard deviation was 3.4. Remember that we're talking about a sample standard deviation here, not a population standard deviation. In step 2, we're going to figure out how wide our histogram needs to be and the number of columns we're going to use. The width of the histogram is based on our range, so from 75 to 62.5 gives us a range of 12.5. I mentioned that we need to try to use an odd number of columns. That just makes the histogram look a little bit better. I chose 5 here. You could choose 7, you could choose 9. I would not choose anything less than 5, and I would probably not choose anything probably bigger than, say, 7 for this particular set of data because we don't have a whole lot of points. If we had a lot of points, then we may choose higher numbers. In step 3, we're going to figure out the range of each individual column and the cutoff points. So we're going to take our overall range, which is 12.5, divided by our number of columns, which is 5, which gives us an individual range for each column of 2.5. So our cutoff points then are 62.5, 65, 67.5, 70, 72.5, and 75. That's just so that we have an evenly spread histogram. In step 4, we're going to put in our bars based on the number of data points that fall in each of those ranges. So for example, from 62.5 to 65, we had 2 numbers in our list that fall between those 2 numbers. From 65 to 67.5, there's only 1 number, etc. Please note that any point that lands right exactly on that cutoff point always goes in the upper side. So for example, 67.5 goes into the yellow bar as opposed to the orange bar because it's part of the second set. And then the last thing that we're going to do is we're going to describe this. So in interpreting our histogram, we use a 4-piece description. We describe the shape, the center, the spread, and the outliers. So for shape, this is roughly symmetrical. It's not exactly. Obviously, if that orange bar was a little bit taller, it would be very symmetrical. But it's okay to say roughly. That's actually an okay term there. Our center is centered around the mean. If you notice, 68.8 would fall almost exactly right in the middle of this histogram. With our spread, it's pretty evenly spread. Yes, there are 5 numbers on the right side, and there are only 3 numbers to the left side. And that is up our yellow bar. But for the most part, it's pretty evenly spread. And then there are no obvious outliers. So how would we know if there were obvious outliers? Say, for example, if we had an extra height added in there that was, say, 78, that jumps and there's like a big gap between that number and the next lowest number. That's when we look for those outliers. We can definitely go back and refer to what we did with the box plot where we actually calculated outliers, and we already know based on the box plot that there were no outliers in this at all. So anytime I ask you to construct a histogram, I'm really looking for not just the histogram itself, but also that description with the 5-number summary, and I'm sorry, not the 5-number summary, the shape, center, spread, and outliers.